All right, so we want to figure out which sigmoid function to use, which means that we want to somehow find out how close a given sigmoid function is to our collection of red and blue points. So central to that is the concept of log loss, and log loss is basically the penalty you pay for assigning a particular probability to a particular point. So for instance, let's move over here to 2. So remember that this represents a score that a particular point would have, an individual would have. So we've got this red point here with a score of 2. And the sigmoid function says we're saying that this is the probability that this is a red point. If we move over here, we're saying this is the probability that this is a red point. Okay? So let's think about things on this side first. So if this point is red, and here we are giving it a very low probability of being red, which means essentially we're saying that it's blue. We're very confident that it's a blue point. And so this is wrong, right? This is a mistake. So we should pay a large penalty for assigning this probability to this red point. So how do we pay such a large penalty? Well, the actual distance here is short. But if you take the logarithm of that, it will be very large, because probabilities, remember, are between 0 and 1. And if you take the logarithm of something close to 0, it's negative, but it's really large. And if you take the logarithm of something close to 1, it's almost 0. So that's what we do. We take the logarithm so that we get a big penalty here. And we also use the negative sign so that it's not negative. And so over here, I've got the probability here, and I'm taking the log of it here. And so we can see the penalties that we pay for assigning particular probabilities to this red point. So if I move over this way, right, we're basically saying that's got to be a blue point, but it's red, so we need to pay a high penalty there, and we are. That's the penalty. Over here, we're doing the right thing, right? We're saying, okay, we've got a point that has this score. We're saying with a lot of confidence that this is a red point, and that's right. So we pay a very, very small penalty. And then, of course, there's in between. Okay, so large penalty. This is small, but the logarithm is large. Right? Penalty, this is large, but the logarithm is small. So we're making mistakes here, large penalty. We're not making mistakes here, small penalty. So that's if it's a red point. So if it's a blue point, we'll come down here. And if it's a blue point, let's go over this way. All right. And so here, remember that this represents the probability of being a red point. All right. So if this is large here, right, 1 minus p is really, really small. So we're saying, okay, this blue point has, so the probability, essentially the probability of being a blue point, we're saying is this distance right here. It's really, really small, okay? But it is blue. So we should pay a high penalty for this. So take the logarithm, always with the negative, and we pay a high penalty. Over here, oh, sorry. All right. This right here that is the probability that we're assigning that point of being blue. All right, we're giving it a very small probability right here of being red. But that's right. So we should not pay a high penalty. And so that's what we have over there. So it's almost the same. It's just the log of 1 minus p, because if p is the probability of red, right, 1 minus p is the probability of blue. And so there you have it, okay? And so when you have a collection of red and blue points, you want to calculate the log loss for every point and add it up. And that's the way that you can decide how well your sigmoid function is doing. You want that to be as close to 0 as possible, because you don't want to pay these high penalties. So in the next video, we'll take a look at that. I'll put all the points out here, and we'll add up all of the log loss and see how we do.